So I'm doing this because there was a question that stumbled a lot of us. Okay. Let's talk about the expectation of objects that is floating in water. Now, first thing about water, you must know is the density of water. The question may not tell you, but it's good to memorize the density of water as being 1 gram per cm cube. So if you're supposed to convert this to kg per meter cube, you may have known the shortcut already. You multiply the value by 1,000. So this is the thing that I want you guys to memorize. If you put something into this water and the density is lesser than water, you will know because you're going to see it float above water. So when it starts to float, can we agree that the density, I just put D, it's actually less than 1 because it's floating. Understand this? Now, there are many ways the object can float. You can float like this. You can float where only a little is submerged, a lot more is protruding outwards. Or you could also float in this manner where just a little bit is showing above. Understand? So these are some variations to consider. But there is one variation that is interesting. I want to talk about this. Now, what do you do, or what do you think if I have an object where the density is actually 1, exactly the same as the density of water? Where do you think you can find this object? Do you agree that it can be like this without any protrusion, no protruding parts, right? Yes? Now, this is not the only answer. This is not the only answer. Joshua, can you tell me what other possibilities can we have if the density is actually equal? Any idea? Not sure? Okay. This is the part where it gets interesting. You can push this block into any part of the water and it will stay there because the density is the same. When the density is the same, it doesn't have to be just on top. It can be anywhere now. It can even be sinking. So how do you know that the density of the wooden block or whatever object is exactly the same as the material that you're submerging in? You know it because when you shift the box, you use your finger and you push it around, it just stays at the final position. There's no attempt to float again. That means you know the density is the same. Are we clear on this? Okay. I give you time, you copy this now. Okay, copy this now. I will also add some text here as well. Okay, so why am I teaching this? Because we came across a question that looks something like this. Okay, so the question gave a scenario where there is water and then there is a wooden block that is submerged. In the diagram, the wooden block wasn't entirely submerged. So straight away, we know that the density is not the same as water. But in the question, they give you the mass and the volume, and you can actually calculate that the density is 0.75. And then this question says that there is actually an opening for the water to be collected. And we are interested to know what is the volume. So, by the way, for this question, the mass that was given to us was 80 grams. And then the volume, no, actually it was 60. I think I said wrongly. And then the volume, it's 80 cm cube. Okay, that is why we could say that the density is 0.75. You take the mass over the volume, we get 0.75. So the question is, what is this volume supposed to be? And how are we supposed to figure this out? So to do this, it helps if you can ask yourself, what if this submerged object has a density of 1? Then we know whatever that is collected will be the exact volume of this object here. Let's assume it's the same box we are talking about. Okay, let's say the volume of the box is 80 cm cube. Because we know that this has the same density, you can submerge it entirely like this, and then it will not float. Then the volume collected will have been 80 cm cube. So I'd like to remind you that this example here is not difficult to understand. But you can also tell yourself, what if there's another scenario where this object is exactly half submerged? Half submerged. Scenario B. So under what circumstances do you think that the object will be floating such that half is above and half is below? The density obviously will be less than 1. But you may have an impression that this must be exactly half the density of water. Again, the density of water is 1, like I said. So when the density is half, then it may be logical to you that half of it will float and half of it will not. So if this was the case, then how much volume will we collect? Since only half is submerged, you can say I'm only collecting 40 cm cube. Are you all following this so far? So now let's go back to this scenario here. I have one extreme which is same. I have the other extreme where this is half. Now the question given to us is 0.75. You may start to say, okay, if it's 0.75, that means it's perhaps 75% submerged. Make sense? Because when it was 0.5 compared to this 1, this is 50% submerged. And when this is 1 compared to the density of water, which is 1, it is 100% submerged. But now this is 0.75 compared to the density of water, which is 1. So if you know that this is 75% submerged, you can take 75%, multiply by the volume of this block, which is given to us as 80, then you can get the answer. Okay, this is actually going to be 60 cm cube. All right. Any questions for me here? I'll pause right. Yes, I see some questions. Yeah, go ahead.